So now we're looking at the rate of reactions and how we measure it and how we graph it. So what is the rate of reaction? Well, a rate is just like anything. A rate is a constant change in something, such as speed or such as anything else. Okay? So when we look at a rate in terms of a chemical reaction, what we're looking at is the rate of the change in concentration over the change in time. Just like we look at velocity. So we look at the velocity of something, how fast something is, over a period of time. It's a similar concept. In this graph here, we see the relationship as well between the reactants and the products. So on the y-axis, we have the concentration, as we can see here. And on the x-axis, we have time. So as time goes on, the concentration changes. So if we were to have A plus B equals AB, we're actually getting a breakdown of A and B in the reactants. So the reactants, the concentration of these reactants is dramatically dropping as the concentration of the products is dramatically rising. What you'll also notice about this graph is that it is not constant. So if it was constant, it'd be a linear graph. So linear meaning a straight line. So as you'll see here, that would be the constant change in the concentration. We can also tell by these marks down the bottom. So if we were to measure the concentration at this mark in time, at this mark in time, and at that mark in time, then it would show a completely different concentration. Therefore, we can't say that the rate of change is constant, because it isn't. Similar to that, we can also tell that there is a straight line here, okay? So this straight line means that the reaction has stopped, or that the reaction isn't really occurring anymore. But because these two lines aren't equal, we can't say it is at an equilibrium. But what we can say is that both of these lines are constant in their spot. Therefore, it's a dynamic equilibrium, because there's two different lines that are equal right now, okay? So it can't be an equal line. They haven't converged on each other. They're dynamic. They're separated, and they're going at the constant rate. Now, similar to last video, as we were talking about last video, we're looking at the factors which increase rate of reaction. And as we can see here, using the example of a catalyst, we can see that with a catalyst, the reaction happens far quicker than it happens without a catalyst. So generally, if we were to look at a graph or doing an experiment and we were to see a faster reaction rate, then we generally see on the graph that the reaction happened quite quicker or it happened slower. And then we'd be able to decipher and really evaluate and identify that the rates of reaction were different because there were different factors affecting that rate of reaction.